Now I am taking an example after discussing a lot about the number system, all about rational, irrational, terminating, non-terminating, natural, whole number, integer. The question is how to insert few rationals and few irrationals between two given numbers. As we know, if there is a number line, every point of the number line stands for some rationals and some irrationals. Now the question is that how to insert, that is find 7 rational numbers between 1 by 6 and 5 by 21. We have two numbers, first number is 1 by 6 and the second number is 5 by 21. What we actually need to do, we want to find 7 rational numbers. 7 rational numbers between this and this. Before it, I would like to tell you, between two rational numbers, there lies infinite number of rational numbers. If you have any two rational numbers, as much closely as you can write, but we have a property that order of rational numbers is dense, meaning by between any two rational numbers there are infinite rational numbers can be inserted. You have to remember this property, number 1. Then question is here, a very short example. We have two rational numbers, one is 1 by 6, other is 5 by 21. We want to insert 7 rational numbers between these two. We may insert 7, we may insert 70, we may insert 7,000, 7 lakhs, 7 crores. Whatever number of rational numbers are required to insert between two rational numbers, we can insert. But before it, as you know, numbers, that is rational numbers, are the numbers in the form of P by Q, where P and Q are co-prime, Q is not equal to 0. P by Q, 1 by 6, P and Q both are integers having no common factor. So first one is clearly what? Rational. 5 by 21 is also what? Rational, because P by Q, P is 5, Q is 21. Here P by Q, P is 1, Q is 6. None of the condition having Q as 0 and no number is common. So we can say these are the rational numbers in its simplest form, because P and Q are co-prime. Meaning of co-prime is well explained you, that if HCF of the two numbers is 1, two integers is 1. Before it, we have to make their denominators same. As and when we want to insert some rational numbers between two rational numbers, their denominators must be same. Here denominator is 6, here denominator is 21. What is such number which we multiply with this denominator and this denominator, that they become equal? So first of all, we will see that what is such number. To calculate that number, you can see that this is 6, this is 21. We will go to calculate LCM of 6 and 21. 6 can be written as 2 into 3 and 21 can be written as 3 7 ja 21. LCM of these numbers become, because 3 is a common factor, then into 2 non-common, then into 7. So this become 42. LCM of 6 and 21 is 42. So it's meaning that both the denominators or the denominator of both the numbers must be 42. It is possible that if I multiply this number by 7, if I multiply the denominator by 7, it is mandatory to multiply numerator also by 7. Now we have 5 upon 21 to make it 42. What we need to do, multiply it by 2 and we will multiply this by also 2, because I want to keep the number value of the rational number same. So this converts to 7 by 42 and this converts to 10 by 42. If only two rational numbers are required, I can say 7 by 42 and 10 by 42, there are two numbers What are these? 8 by 42 and 9 by 42 can be easily written, but I am not interested to calculate only two numbers. I want to find how to insert the 7 rational number. Now how to say and what is method to find it like this? 7 by 42 and 10 by 42. Simplest form of 7 by 42 is 1 by 6. Simplest form of 10 by 42 is 5 by 21. But with this special trick, by finding LCM, we have made their denominator same. Now what we can do? We can multiply these two numbers by same number. That is, you can say 70 upon 420 and 100 upon 420. 70 upon 420, 100 upon 420, still these are what? Still these are same as 5 by 21 and 1 by 6. Between 70 by 420 and 100 by 420, it is easy to write many rational numbers like 71 upon 420, 72 upon 420, 73 upon 420, dot. So till what? 99 upon 420. So 71 to 99. 71 to 99, that is what? We can say I have inserted many rational numbers between these two. If you want to insert few more, you just can go to write it like this: 700 upon 4200 and 1000 upon 4200. Now there the space has increased between 700 and 1000. If you want to insert few more, you can say it is 7000 upon 42,000 and 10,000 upon 42,000. So we will multiply 10 and the gap will increase, so we can insert n number of rational number between any two rational number. But step is, first make their denominator same and then you multiply numerator and denominator by some natural number according to as your requirement, how many numbers you want to insert. Between two rational numbers, we can insert any number of rational numbers as well as any number of irrational numbers also. Now I am taking an example where between two rational numbers, how to insert few given number of irrational numbers. Rationals are those which are in the form of P by Q. Rationals are of two types, either terminating or non-terminating but repeating. Irrationals are those which are non-terminating, non-repeating. So for making it clear, be with me to see this example. Insert 50 irrational numbers between 1 by 2 and 1 by 3. What is 1 by 2? 1 by 2 is a rational number. 1 by 3 is also rational number. So I want to insert what? 50 irrational numbers between 1 by 2 and 1 by 3. In order to insert 50 irrationals, it is convenient to convert both these numbers in their decimal form. You know it well, when you are going to convert any rational number in its decimal form, there are two types of possibilities. Type A, where the division will terminate, or type B, where division will not terminate. If division will not terminate, then it will repeat. After how many places? Or on before denominator minus 1. So we can say 1 by 2 is what? 0.5. It's terminating. Why it is terminating? Reason is so simple. Its denominator is 2. Prime factors of 2 are 2 1 are 2. If the prime factors of the denominator having only 2's, only 5's, or both 2's and 5's, then it has to be a terminating. That's why we can say 1 upon 2 is equals to 0.5 is a terminating number. Now what for 1 by 3? To convert this 1 by 3 denominators prime factorization, that is the prime factorization of 3, it is 3 1 ja 3, no 2, no 5, only a number 3. So the property is, if the prime factorization of the denominator of any rational number having any prime number other than 2 and 5, it has to be a non-terminating repeating. So but repetition begun with after how many places? Repetition begun after denominator minus 1 places or before it. Here denominator is what? 3. 3 minus 1 is what? 2. So if I divide 1 by 3, I will get a non-terminating repeating number, and repetition will begin either after 2 places or before it, that is either after 1 place. So you all know 1 by 3 answer is 0.3333 dot dot dot. Sometime few of you can write it as 3 bar, 0.3 bar, okay, having the same meaning. Here repetition has started immediate after 1 place, but in case this maximum, you see denominator is 3, 3 minus 1 2, repetition has to be started in case of the non-terminating rational numbers denominator minus 1 places or before it. So here 3 minus 1 2, so repetition has started after 1 place, not after 2 place, because I am saying again and again, repetition starts immediate after denominator minus 1 or before it. So denominator minus 1 or before it, it is satisfying. I want to find 50 irrationals between 1 by 2 and 1 by 3. 0.5 is the decimal form of 1 by 2 and 0.3 bar or 0.33333 is the decimal form of 1 by 3. I want to insert 50 numbers between these two. So what can I do? I just can say 0.5 can be written as 0.5000. As many zeros I want to write, I can. And next is 0.33333 dot dot dot. It is terminating, so no dot dot dot. It is non-terminating, so I am putting dot dot dot. Question is, what is the number between 0.5 first place and 0.3? Yes, a number is 0.4. 0.4 is a number lying between these two. Now the question raised, I want to write how many irrationals? 50 irrationals. So I have to write 50 irrationals like this: 0.41, 441, 444, dot dot dot, then 0.420, then 200, then 2000, then dot dot dot. Similarly 0.4, you can say 2211, then 222211, then 222211. So you have to begin with what? 0.4, and then you have to write such a sequence where numbers will not repeat. Here 1, then 2 fours, then 1, then 3 fours. So no termination is there, no repetition is there, just a pattern. So you can write, as I have explained you how to write 3 numbers. Similarly, you can write 50, 100, 1000. You just need to write the first digit as 0.4, because 0.4 is coming between 0.3 and 0.5. So this is the way. It is not necessary that you will write the irrational numbers between irrationals and rationals between rationals. No, you can write rationals and irrationals between any rational or any irrational. Now I am taking another example where we will insert few rationals and few irrationals between two given numbers. Example is, insert 5 rationals and 5 irrationals between root 2 and root 3. It is very much clear that root 2 is an irrational, root 3 is an irrational, because one can find their square root up to any places of decimal, no pattern, no repetition, Nothing we can find in any of these two cases. That's why their answers will come in the form of non-terminating, non-repeating, and such numbers are to be taken as irrationals. What we want to do between root 2 and root 3, we are interested to insert 5 rationals and 5 irrationals. I am trying to tell you it is always convenient to bring the decimal form of rational or irrational when you want to insert few numbers between them. Here root 2, you all know in class 8 have been calculated many times and have been asked to you in the examination. 1.414 dot dot dot. It remains non-terminating, non-repeating, and root 3 comes as 1.732 dot dot dot. You have converted both irrational numbers again in the irrational but in the decimal form, because an irrational cannot be changed without multiplication or division in the rational, or any rational cannot be converted in the irrational without any particular multiplication or division. Same here, root 2's value 1.414 decimal representation and root 3 is 1.732 dot dot dot. Now a question is here that how to write 5 rationals. To write 5 rationals, you see it is 1, it is 1. We will say it is 1. Then point, 1 point. It is 1.4, it is 1.7. It is 1.4, it is 1.7. So you can see between 1.4 and 1.7, you can say it is 1.5, 1.6. We can say if you want to write what? Rationals. So you can write 5 rationals like this: 1.51, 1.52, 1.53, 1.54, 1.56. Whatever you want to write, you have to take care that when you are writing a number, it should be more than 1.4 and less than 1.7 and no dot dot dot, because we are trying to write what? Rationals. If you are trying to write dot dot dot, then you have to write the pattern. So these are 1, 2, 3, 4, 5. Similarly, you can say 1.6, 1.61, 1.62, 1.69, 1.51, 1.567. You can write infinite number of rational numbers by just a little bit of the common sense, which start either 1.5 or 1.6, because these are the two values lies between the decimal representation of root 2 and root 3. These are the rationals. Same numbers, these all 5 can be converted to irrational also. How? If you want to say 1.51, then you write 551, then you write 551 and dot dot dot. Then 1.52, 552, 552 dot dot dot. Then you can say 1.53, 553, 553 and dot dot dot. Similarly, you can write, as I have shown here, 3 irrationals. You can write n number of rational, maybe 5, maybe 50, maybe 1000, maybe 500. Whatever you want to write, you can write. But take care, when you are writing irrational, there is a pattern: non-termination, non-repeating. Whenever you are writing the rationals, the pattern should be either terminating, or if it is not, then you write them in the non-terminating but repeating. So this is the way to insert few numbers between the two given numbers. Now we will explain you. Now I will tell you how to represent the rationals and irrationals on the number line. Now I want to tell you how to represent the irrational numbers on the number line. We will use here the Pythagoras theorem. The concept of the Pythagoras theorem is very much helpful for representing the irrational numbers on the number line. See, basic, first root 2. Represent root 2, root 3, root 17, root 19 on the number line. I am taking here 4 examples. With the help of this, you will become quite comfortable. First is root 2. So I have used a word theorem Pythagoras. How can I say that root 2 is what? Root 2 can be written as 1 plus 1. Or root 2 can be written as 1 square plus 1 square. still root 2 is the same, it has the same value. Question raised, what help we want to take from here? The simple reason is, we know that hypotenuse square is equals to perpendicular square plus base square. Meaning by we can say hypotenuse is equals to root of perpendicular square plus base square. So if I equate, I compare, or I use some logic, this formula of Pythagoras with root 2, I say root 2 is equals to 1 square plus 1 square. So what conclusion I am going to draw? Conclusion is that root 2 is the hypotenuse of such a right angle triangle whose perpendicular is of 1 unit and base is of 1 unit. From this discussion, you must be aware that what is root 2? I want to say root 2 is the hypotenuse of that right angled triangle whose perpendicular and base both are of 1 unit. To express root 2 on number line, I am roughly taking a number line. Line is that line segment which is extended indefinitely in both the directions. Here this is the center, Aryabhata's number 0. This is the positive side, this is the negative side. This is positive side, this is negative side. Now I can say, suppose this is 1 unit, this is 2 unit, this is 3 unit, and so on remain to go. Similarly -1, -2 and -3. Okay. What I want to say that I want to draw a right angled triangle whose perpendicular and base both are 1. I have taken here 0. This is 1 unit. Suppose this point is what? Where 1 is written, I am taking this point as P. On this point P, I am going to draw a perpendicular like this. You know what is the difference between perpendicular and altitude? If you can, please tell us on the extra mind. So this is the P, perpendicular is drawn. What is going to be? What is the length of OP? This 0, I am taking this point as O. Same distance as is of OP, you have to cut it on the perpendicular by taking P as center like this. Suppose this is the point Q. I am repeating what I did. O is the center, OP is the distance 1 unit, then another is maybe whatever, second, third, fourth, similarly positive and negative. Now with the help of compass, I have fixed that compass needle at O, opened it till P, meaning by this become 1 unit. This distance I have made cut off on the perpendicular which is being drawn on P. This point is suppose coming as Q. If Q is joined to O, now Q is joined to O, then what you can say? OPQ is a right angled triangle. Right angled triangle with base OP as 1, with perpendicular PQ as 1. So with the help of Pythagoras theorem, we can conclude its hypotenuse is coming root 2. Root of 1 square plus root of 1 square is equals to root of 2. Now conclusion is coming that OQ is equals to what? Root 2. This part OQ is root 2, this part OQ is what? Root 2, but actually it is not on number line. To bring this part OQ on number line, take the compass, fix its needle at O, open it till pencil Q, and then mark an arc like this. So we will get a new point, suppose M, which is somewhere between 1 and 2. This length OM on the number line represents root 2 because as the arc OQ is equals to OM. OQ is root 2 because of the Pythagorean condition, and OM and OQ are equal because of the compass and pencil. We have mark an arc, so the two radii are equal. So in this way, root 2 is what? OM. I have explained you how to express root 2 on the number line. Basic number, first number. In order to represent any irrational number on number line, we will always take the help of Pythagoras theorem. We will see that given number can be expressed in the breakup of what, and then that can be utilized with the base and perpendicular and hypotenuse. So come is the same irrational number, and with the help of compass that hypotenuse can be plotted, converted and search a point on the number line. I will explain you how root 3, root 17 and root 19 on the number line also. Now I want to explain you how this root 3 can be expressed on the number line. Because I want to express root 3, so I will think that there must be two numbers whose sum of squares is 3. To convert in Pythagorean triplet, as I told you initially, what we did, root 2 we have written 1 square plus 1 square. So root 2 is the hypotenuse of that right angled triangle whose base and perpendicular both was 1 1 as discussed with you. So on the same pattern, if I try that what are the two numbers whose sum of squares is root 3, if so, if I can trace, it is not possible. That is, I will say before root 3 I must know how to represent root 2 on number line, because no two natural numbers are possible whose sum of squares is 3. So I can say it can be written as root of 2's whole square plus 1 whole square. Its meaning by, first I need to represent root 2. First I need to represent root 2 on the number line. Then with the help of that base and perpendicular 1, I will construct such a right angle triangle whose base is root 2, perpendicular is 1, then its hypotenuse will be automatically root 3, and that can be bring out with the help of the compass and pencil on the number line. This is suppose O, this is P, 1 unit, then perpendicular, then 1 unit, Q, this is 1, this is 1. So Pythagoras theorem says this is root 2. With the help of pencil and compass, when we have drawn mark an arc by taking O as center and OQ as the radius, this point is M, and this M point, that is OM, become root 2. If OM become root 2, now root 2 is the base and 1 unit is the perpendicular. On M, draw the perpendicular again, and here after drawing the perpendicular, cut it again 1 unit, exactly equal to OP. Suppose this point is R, join this to O. We say OMR is right angled triangle with base OM is equals to root 2 and perpendicular OR 1 unit. So Pythagoras theorem implies hypotenuse is equal to root 3. Hypotenuse is OR, that is root 3. To bring the hypotenuse on the number line, take O as center, OR as radius, mark an arc. We will get to know, suppose this point is N, ON is on number line and is equals to root 3. Now how to represent this root 17 on number line? As initially we will think of that what are the two numbers which are the perfect square and their sum is 17. Numbers are 16 and 1. Can be written as 4 square plus 1 square. Meaning by we have to draw a right angled triangle whose base is 4 and perpendicular is 1. Its hypotenuse will be automatically root 17. See here, this is the number line. This is 0, 1, 2, 3, 4, 5. 4 means root 16. This is in all I can say OM. At 4 I am mentioning point M. At 4 draw the perpendicular, that is 90-degree angle with the help of compass, and cut it equal to 1 unit. That is what? O. Suppose this is P point, OP. Equal to OP, cut here 1 unit and join that point, suppose R, to this O. So OR is the hypotenuse of that right angled triangle whose base is 4, perpendicular is 1. So automatically the hypotenuse will be what? Root of 17. Now the question raised, how to bring this root 17 on number line? It is as usual so simple. Take center point as O, OR as radius, mark an arc. This point is suppose N. Then we say ON is equals to root of 17. So there is no difficult. There is nothing is difficult in the way of strong determination. So you have to determine that what you really want to do. Now the last, root 19. How to represent root 19 on the number line? In order to represent root 19 on number line, again we have to think for two such numbers whose sum of squares is 19, but there are no two perfect such numbers. So first of all, we have to think that before root 19, we need to calculate root 18. It can be written as root 18 square plus 1 square. Now the question is, root 18 can be written as root of 17 square plus 1 square. But root of 17 can be written as 4 square plus 1 square. So in order to express root 19 on the number line, we must know how to represent root 18. To represent root 18, we must know how to represent root 17. And root 17, I have represented previous to it. I am taking a longer number line. This point is 0, this is 1, this is 2, this is 3, this is 4, this is 5. This is root 16 this much on this 90-degree angle. 1 unit cut and join to this point O, and with the help of compass, this is root 17, M point or N. Now on this root 17, again 1 unit and joined when this become root 18. On root 18, again 1 unit joined, so this become root 19. So we can represent any irrational number on number line. Now the question is how to convert the given rational number in its decimal form. Decimal form of a rational number is nothing, it is just division of numerator by the denominator. Suppose I take an example 22. If I take an example, it is suppose 22 by 7. So before I start dividing, I must have a thought that its division will be terminating or non-terminating. The division of those numbers will be terminating whose rational numbers denominator is having the factors only 2's, only 5's, or both 2's and 5's. If it not so, that is the rational number whose denominator is such that when we go for its prime factorization, we find any other prime number than 2's and 5's. So it is very much clear. The prime factors of the 7 are 1 into 7. So the decimal conversion of 22 by 7. Decimal conversion of 22 by 7 will be what? Non-terminating, repeating. Now repetition after how many places? How long we have to keep the patience? Whatever written in the denominator is 7. subtract 1 from it, becomes 6. So the decimal conversion of 22 upon 7 will repeat on or before 6 places. Its answer to be taken as 3.142857. 142,857 dot dot dot. That is 3.142857 bar. How many places are taken? 1, 2, 3, 4, 5, 6. What is here? 7. 7 minus 1, 6. So repetition will begin after how many places? 6 places or before it. So this is the way of expressing the rational numbers in their decimal form, the simple division. Only a thought, skill, or only a trick need to remember. You can check whether it is terminating or non-terminating by just simply getting the prime factors of the denominator. But always remember, whenever you are prime factorizing the denominator, before it you need to check whether the rational number is in its standard, that is the simplest form or not. Because somebody says 3 upon 12, tell this is terminating or non-terminating. If you run directly, you will say denominator is 12, its prime factors are 2 into 2 into 3, any other number than 2s and 5s is coming. So what? This become, we say it is 2 into 2 into 3, 3 is occurring here. So what we will say? We will say it is non-terminating, repeating. But we have not checked. Its simplest form is 3 1 ja 3 and 3 4 ja 12. So it is 1 by 4 basically. And actually if you factorize 4, you will get 2 into 2. So only 2's are here. So it is what? It is a terminating. So my simple submission is to you, before you convert any rational number in its decimal form, you must check its simplest form, whether it is in simplest form or not. And if not, so convert it. After converting, check the prime factors of denominator. See the condition of 2's and 5's one. If it's so, may be terminating or may not be terminating. If terminating, go for its the termination 1 upon 4. Answer of 1 upon 4 is 0.25, terminated. And answer of 22 by 7 is 3.142857. 142857. 142857. That is, repetition has started after 6 places because denominator is 7. If somebody says 1 upon 13, after how many places that repetition will begin of this question? The repetition when 1 will be divided by 13 will begin either after 12 places or 1, because denominator is here 13. Now second type of problems, that is how to convert the decimal number in the form of the rational. That is, the number given is the rational to the which one. Previous to it I told you how to convert a rational in the decimal form. Now reciprocal of it, converse of it, that how to convert a decimal number in the form of the rational. Suppose I convert the following decimal numbers in the form of rational numbers. First is 0.3 bar, 6.21 bar, third 18.265 bar. These are the all such numbers where the non-termination is indicated, because if bar is being put on any number, it shows it is a non-terminating repeating number. If I take the first example, that I want to represent 0.3 bar on the number line. If 0.3 bar I want to put on the number line, I am taking this value as x. I can write this as x is equals to 0.333 dot dot dot. It is the expanded form because it is 3 bar. So it is 3 bar bar bar, that is 0.333. This is the equation number 1. always remember that decimal must be on that position, that place from where repetition starts. So decimal is on the position immediate after repetition is starting. Second observation, check that how many digits are repeated. Only one digit is repeated. Remember, if only one digit is repeated, multiply the equation both sides by 10. If two digits are repeating, multiply the both sides of equation by 100. If three digits are repeating, multiply both sides of equation by 1000. So here what I will write, on multiplying equation number 1 by what? 10. So this will be 10x is equals to, when I multiply by 10, decimal will shift to one place. This will be 3.33. You have to check, I am putting the decimal here. So this will seems to you 3.33, but there are infinite 3's. So I am writing one more 3 dot 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 equation 2. From equation 2 subtract equation 1. Subtract equation number 1 from 2. So I will write 10x is equals to 3.333 dot 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 and x is equals to 0.333 dot dot dot. If I subtract 10x minus 1x, that is 9x. Then I will tell you 3 minus 3 0, 3 minus 3 0, 3 minus 3 0. So nothing will left after the decimal, because after the decimal in equation number 2 also 333 and equation 1 also 333. So 3 minus 0 only is 3. So x is equal to 3 upon 9. This become 1 upon 3. So I can tell you, or you can say that 1 upon 3. This 1 upon 3 is the rational form of 0.3 bar or 0.333. So this is the way to convert a decimal number in the rational form. I will tell you the two more examples with this. Now how to convert 6.21 bar in the form of P by Q, that is in the form of the rational number. So if I take the second part, same way I will say let x is equals to 6.21 bar. 21 bar means both the digits 2 and 1 repeats infinite times. That's why I can say x is equals to 6.212121 dot dot dot. First checkpoint is that decimal should be on that place where from where repetition is starting. Here point is here 212121. So decimal is already on its correct position. Second step, observe that how many digits are repeating. Two digits, 2 and 1. 21 21 21 21. So I told you, if one digit repeats, multiply the equation both sides by 10. If two digits repeat, multiply by 100. If three digits repeats, multiply by 1000. So what is your answer? By what we will multiply? We will multiply it by 100. So I will write here, on multiplying equation number 1 both sides by 100. If I multiply by 100, this will be 100x is equals to, when it will be multiplied by 100, this one decimal will shift 2 places right side. This becomes 620.2121. I can take one more 21 because there are infinite 2 ones. Equation number 2. Subtract equation 1 from 2. Subtract equation 1 from 2. This is 100x is equals to 621.212121 dot dot dot. You have to write here dot 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 also. And x is equals to 6.212121 dot dot dot. If I subtract 100 minus 1, 99x, and you can find here 2 1 2 1 2 1, nothing will be after decimal, that will be 0. 11 minus 6, that is what? 5 1 6. X equals to 615 upon 99. You can convert it in the simplest form, that is 3 3s are 3 3s are, then 3 2s are 3 5s are. So 205 upon 33 is the value for which the decimal non-termination form is 6.21. Now I am telling you the most difficult example, because level of difficulty is increasing, easier, a bit difficult, and then more difficult. I am explaining you how to convert this 18.265 bar in the form of P by Q. Again, first step is same. We will say whatever we want to convert, let that value is x. X is equals to 18.265 bar. Here, point to note is bar is not on 2, bar is only on the 6 and 5. First step is the decimal putting on the place from where repetition is start. First of all, you will have to write it is 18.2656565 dot dot dot. Here decimal is before 2, but 2 is not repeating. So by any of the approach, first of all decimal must reach before first 6. What is the approach? We will multiply it by 10. On multiplying equation number 1 by 10. Why? To bring the decimal on the position where actually it is required. So x is equals to 18 2, that is 182.656565 dot 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 equation 2. Now this question has come in that shape, that is from where repetition starts and decimal is on the right position. After this step is what? As many digits are repeating, according to that either multiply by 10 or by 100 or by 1000 or by 10,000 or by lakh. Here only 2 digits are repeating. So we will multiply equation number 2 by 100. On multiplying, I have multiplied this equation by 10. So this will be 10x, which I forgot to write. On multiplying equation number 2 by 100. Why? Because here 2 digits are repeating. Why I have multiplied this equation before by 10? Because decimal needs to be sent on the position from where repetition is starting. And here decimal was before 2, 2 was not repeating. So that's why in order to send the decimal before 6, I need to multiply it by 10. So when I am multiplying equation number 2 by 100, this will be 1000x is equals to 182 then 65, because on multiplying 100 this will shift here 0.656565 equation 3. Subtract equation number 2 from 3. Subtract equation 2 from equation number 3. We will get 1000x is equal to 18,265.656565 dot dot dot, and 10x is equals to 182.656565 dot dot dot. If we subtract 1000 minus 10, 990x. After decimal, there will be 0. 5 minus 2, it is 3. 16 minus 8 is the 8. 1 minus 1 is the 0. Then it is 8 and then it is what? 1. So answer of x is 18083 upon 990. If need be, you can convert it in the simplest form. Otherwise, the same will be the answer. Now I am taking an example where I will have to show that the given number is y irrational. I am taking example here, prove that root 3 is an irrational number. Some questions, root 2, root 5, root 17, 1 by root 2, 3 root 2, 5 plus root 2, 3 minus root 2, all these type of problems can be solved, can be given the logic. Question is, prove that root 3 is an irrational number. I will prove this question by two approaches. Approach 1 with the contradiction method. What is that method? I will say let root 3 is a rational number. I will write here, if possible, let root 3 is rational number. So definition of rational number is what? If it is rational, then it can be converted in the form of p by q, where p and q are integers, q is not equal to 0, p and q have no common factor, or p and q are co-prime. So this implies root 3 is equals to p by q, where p and q are co-primes and q is not equal to 0. Root 3 is equals to p by q. On squaring both sides, I will say 3 is equals to p square upon q square. Or I can say on cross multiplying, you can say that 3q square is equals to p square, equation number 1. With the equation number 1, what we can conclude? We can say the left hand side LHS of equation number 1 is multiple of 3. Clearly 3 is multiplied here. So LHS of equation number is one multiple of 3. But we have LHS and RHS are equal. As LHS is equals to RHS, so we can say RHS is also multiple of 3. If RHS is multiple of 3, then we can say p square is multiple of 3. If p square is multiple of 3, we can say p is multiple of 3. This is the conclusion number 1. Or I can represent this by equation number 2. What I did, I am trying to prove that root 3 is rational. To prove it, I want to prove that root 3 is irrational. I have assumed that root 3 is rational is equals to p by q, where p and q are co-prime, q is not equal to 0. So root 3 is equal to p by q on squaring both sides. On squaring both sides, I have received 3 by 1 is equal to p square by q square. On cross multiplying, 3q square is equal to p square. Clearly 3q square is multiple of 3. So LHS is multiple of 3, but LHS and RHS are equal. So RHS is multiple of 3. So p square is multiple of 3. So p is multiple of 3. So I can say p is equals to 3m, multiple of 3. Put this value of p is equal to 3m in equation number. I am writing here, put p is equal to 3m in equation number 1. So if I put this in equation number 1, equation 1 will get converted to 3q square is equal to p square means 3m. That is 3m into 3m. 3 and 3 cancelled. This left with q square is equal to 3m square. Now this is result number 3. In this equation number 3, what we are finding, RHS is multiple of 3. Clearly you can observe here 3m square multiple of 3. LHS is equal to RHS implies that LHS is multiple of 3. LHS means q square is multiple of 3 implies that q is multiple of 3. This is the conclusion. That is q is multiple of 3. I can say result number 4. From result 2 and 4, what I can conclude? P and Q from 2 and 4, P and Q both are multiple of 3. But initially what I have accepted that P and Q are co-prime having no common factor, and with the help of result 2 and 4 I am saying they have 3 in common. Hence our supposition is wrong. Supposition is wrong. What? we have assumed root 3 is rational. So this implies root 3 will be irrational number. Result A. What is the another approach? Another approach is you have to calculate the value of the square root correct up to 3-4 places, and you will notice that neither it is terminating nor it is repeating. So you will say it is what? Irrational number. So every problem based upon where you want to say it is irrational can be explained, can be proved like this. This is one of the master result, basic result I have told you. Now another important question where we will prove that sum and product, sum as well as product of a rational with an irrational is always irrational. So what the question want to, that if you have rational number, another irrational number, if you want to add or multiply, if you want to find sum or product, if you want to find the sum and product of a rational with an irrational, the result is always irrational. What is this? So in order to explain you, I am saying like this, that let A is any rational number, A is any rational number, and B is any irrational number. A is any rational number and B is any irrational number. First part, what I want to prove, that the sum of A and B, that is A plus B, is irrational. I want to prove that if A is any rational number, B is any irrational number, then sum of a rational with an irrational is always irrational. In order to prove this question, again I am going to take the help of contradiction method. If possible, let A plus B is a rational number, suppose R. A plus B is a rational number and that is equals to R. Or if you want to take, you can say it is P by Q, where P and Q both are integers having no common factor, Q is not equal to 0. I can say that answer of B is equals to P by Q minus A. What I did, I shifted this A from here to right hand side. P by Q is a rational number, as I have taken that sum of a rational with an irrational is rational. Contradiction, wrong assumption. B is equal to P by Q minus A, that is rational minus rational. You can observe from here that left hand side LHS of equation number 1, left hand side is what? B is what? Irrational. Why it is irrational? As we have assumed A is any rational, B is any irrational. B is irrational, B is irrational, so left hand side of equation number B is irrational. Now we are coming to the right hand side, RHS of equation number 1. What is right hand side? P by Q minus A. P by Q is rational, A is rational. Why A is rational? As assumed, we know that sum, difference, multiplication and product, sum, difference, product and division of two rational numbers is always rational. Right hand side is what? The difference of two rationals. One is P by Q, other is A. So right hand side of equation number 1, that is P by Q minus A, is rational. So what conclusion comes from this discussion? This implies LHS is not equal to RHS because irrational can never be equal to rational. Hence, our supposition is wrong. So what we will conclude? We will conclude that sum of a rational with an irrational is always irrational. This is the first proof. I will explain you second proof, that is in case when there is a rational another is irrational, product will also be irrational. Now in order to explain you that product of a rational with an irrational is also irrational, how we will make it proof? Let A is what? Rational number. A is the rational number. B is what? Irrational number. What we want to do? We want to do that A into B. We want to prove, what we want to prove? A into B is a irrational result, irrational number. We will also show the same proof by the contradiction. If possible, let A into B is rational. So you can say A into B is equals to P by Q, where P and Q both are co-prime, having no common factor, Q is not equal to 0. So from this discussion we can say B is equals to P by Q into A. What is this B? B is the right hand side and it is irrational. So right hand side, that is B is irrational. B is irrational, and left hand side P by Q into A is rational. Why P by Q into A is rational? Its simple reason is that P by Q is assumed rational, A is also rational. We know that sum, product, difference and division of two rationals is always rational. So when P by Q divided by A become P by Q into A, this become a rational. This become a rational. So RHS is what? Here we will say it is LHS. LHS, that is B is irrational, as clear from here. Here it is RHS. RHS P upon Q into A is rational. So what conclusion you can draw? You can say LHS is not equal to RHS. This implies result A into B is what? Irrational. It is not rational, because if I am assuming it is rational, we are reaching to a contradiction. So A into B, that is the product of a rational with an irrational, is always irrational. Now a special type of representation where the mean proportion is applicable. So someone says represent root of 4.7, root of 9.3 on the number line. First of all, you draw any ray. Suppose this is ray OX. What we want to represent root 4.7? To represent root 4.7, you have to take the compass, put the needle at O, mark an arc with the length of 4.7. Suppose this is coming at the point A, number 1. After it, this OA how much we have taken? 4.7 units centimeters generally we take. So OA is 4.7, and after it the standard is we have to increase from A to B only 1 unit. Take the compass, take the radius 1 unit, fix the needle of the compass at A and mark it, this B. So we can say AB is equals to 1 centimeter. This is 1 centimeter. I can say AB, this is OA. Now we will draw the right bisector, perpendicular bisector of the length OB, perpendicular bisector of OB. Suppose this perpendicular bisector of OB is meeting somewhere OB at midpoint. Locate that point as C. Taking C as center, CB or CO as radius, because CB and CO are equal lengths, draw a semicircle like this. If this is the semicircle, now at point A, where we have taken OA 4.7, draw a ray or draw the perpendicular, suppose AY, which meets the semicircle at a point P. join P to O and P to B. Join P to O and P to B. This length AP is equal to root of 4.7. Now question comes why? You know angle OPB is 90 degree because angle in semicircle is always 90 degree. Now I can tell you using the similarity concept that remember there is a result in class 10th. If ABC is a right angle triangle, the length of perpendicular drawn from the right vertex to the hypotenuse, suppose D. That length of the perpendicular square BD square is equals to AD into DC, product of the lengths of in which the hypotenuse is divided by the perpendicular drawn from the vertex to the hypotenuse. Here in this triangle OPB, PA is perpendicular to the hypotenuse OB, so you can say AP square is equals to 2 parts OA into AB. So you can say AP square is equals to how much is OA? 4.7. How much is AB? 1. So you can say AP taking square root of both sides is 4.7. So same way we can represent root 9.3. What change will be there? Only a minor change. What is that? As we have taken OA 4.7, we will take OA 9.3. And again after it 1 centimeter, remaining all processes are same and proof will be same. Now another representation. Represent 3.765 on number line. How? We have to draw a number line where it is 0, 1, 2, 3, 4, 5. Left side -1, -2, -3, etc. 3.765. This result 3.765 lies between 3 and 4. So this is 3, this is 4. If I make 10 equal parts, suppose this is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. I am taking this part is bigger here, so that it will be very much clear to you that how we can make it. It is suppose 0, it is 1, it is 2, it is 3, it is 4, it is 5. It is 3.1, you can say 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4. So it is 3.7. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. This is 3.7 and this is 3.8. I am taking here and I am going to make it magnifying. This is 3.7 and this is 3.8. These two. Between 3.7 and 3.8, 3.76 lies. So this I am taking as 3.7, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 3.71, 72, 73, 74, 75, 76. This is 3.76 and this is 3.77, 3.78, 79 and this last is 3.8. Between 3.76 and between 3.77 there lies what? There lies this one, 3.765. This is 3.76, this is 3.77. Between these two I am dividing in 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I cut a rope 2 times, there will be 3 pieces. If I cut a rope 1 time, there will be 2 pieces. So I am taking how many parts? Here 10 parts by drawing how many? 9 verticals. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 parts. Now this is 3.761, 3.762, 3.763, 3.764 and this is 3.765. So this is the way with the help of taking the magnifying parts for representing the longer decimal positions. Now another representation, represent 5.37 bar on number line. In order to represent where bar is given, there are two approaches. A, you can convert it in its form of the rational number, or B, with the help of the magnifying image. So I am telling you with the second approach, that is how to express 5.37 bar on the number line. Suppose I am taking it like this. This is 0, 1, 2, 3, 4, and I am taking this longer because I need to represent, and this is 6 and minus 1, left side minus 2, etc. First I need to take 5.3. So if I take here 4, it is 5, then I can take 6 and 7. This is 5, this is 6, 5.3 means 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9 and 6. So this is 5.1, 2, 3. This is 5.3 and this is 5.4. Between these two there will be some position like this 5.3, 1. This is 5.3. This is 5.4. If I am magnifying it, this is 5.31. 32, 33, 34, 35, 36, 37, 38, 39 and 5.4. This is 5.37. 31, 32, 34, 35, 36, 37. And this is 38. This is 5.37. This is 5.38. So in between these two, I can take here, this is 5.37 bar. So we are very closer between 5.37 and 5.38. So this is 1, meaning by 5.371. 5.372, 3, this is 4, 5, 6, 7, 8, 9 and this is 5.38. So I need to represent 5.3777 like this. So this is more than 5.37 and less than 5.37. It is more than 5.377 and less than 5.378. So this is 5.371, 72, 73, 74, 75, 76, 77. And this is 5.378, 5.377. Now if we come that we are observing that there will be again what? 10 parts, 5.377. This is 5.3771 and 5.3779 and this is 5.378. So like this, by putting 2-3 more images, we say this is the value of 5.37 bar. Now prove that few numbers, how these are irrational. After taking the main results, if we club few results, then how we will explain. For example, prove that 3 root 3 first result, 2 plus root 3 second result, 7 minus root 6 are irrational numbers. In order to prove, there are two approaches. One, it depends upon the length of mark of the question. Suppose it is a short marks question like this first part, 3 root 3. You need to prove it is what? Irrational number. In order to show it is irrational, what we will do? As I have explained to you, there is a theorem that the product of a rational with an irrational is always irrational. So I have assumed let 3 root 3 is a rational number and is equal to p by q, where p and q both are integers having no common factor, q is not equal to 0. So I can say root 3 is equal to p by 3q. Here a method of contradiction starts, that root 3 is what? Irrational. P by 3q is what? Rational. So LHS is not equal to RHS. If LHS and RHS are not same, then it means that what we have assumed that 3 root 3 is a rational, p by q is a wrong assumption. So if number is not rational, it has to be irrational. So what conclusion comes? That 3 root 3 is a irrational number. So as any question, where we want to show that it is irrational, we have to take with the method of contradiction, let it is rational. Like 3 root 3 is equal to p by q, rational number, integers, no common factor, q is not equal to 0, 3 is transferred, root 3 is equal to p by 3q. As p by q was rational, 3 is rational, so p by 3q is a rational, RHS rational, LHS irrational, hence these two values are not equal, so our supposition is wrong, that's why 3 root 3 is irrational. Now I want to show you that how 2 plus root 3, how 2 plus root 3 is the irrational number. In order to show this result, again I will assume that let 2 plus root 3 is what? Rational. If it is rational, then I will say 2 plus root 3 is equal to p by q, where information p and q both are integers having no common factor and q is not equal to 0. Now this implies root 3 is equal to p by q minus 2, or you can say root 3 is equal to p minus 2q by q. Ultimately same thing is coming here. Root 3 is irrational, this is rational. So LHS is not equal to RHS. Now sometime a question may raise whether we need to prove that root 3 is irrational. Yes, if the length of the marks, the question is having heavy weightage, we have to show that root 3 is irrational. If it is not so, 1 marker or 2 marker, it is convenient. So this implies we say what? 2 plus root 3 is a irrational number. Similarly, we can show 7 minus root 6 is also irrational. So it's a very easy to show these results. Now I will explain you by taking some examples that why sum of two irrationals can be rational, difference of two irrationals can be rational, etc. Now I will take some examples of few irrational numbers whose sum, difference, multiplication, division is the rational number. So by giving example that sum of two irrationals can be a rational, difference of two irrationals can be a rational, product of two irrationals can be a rational, division of two irrationals can be a rational. So if I take first, if one of the number I am taking 2 plus root 3, another I am taking suppose 4 minus root 3, this number is b is equals to 4 minus root 3. So a plus b is equals to 2 plus root 3 plus 4 minus root 3, that become what? 6. So 2 plus root 3 is a what? 2 plus root 3 is the irrational number, because sum of a rational with an irrational is always irrational. 4 minus root 3, difference of a rational and irrational is always irrational. These are the two irrational numbers whose sum is coming 6, which is natural, whole number, integer and rational. Second example, if I take like this root 3 minus 7, one of the number, and then 10 plus root 3 is another number, their difference root 3 minus 7 minus 10 minus root 3. Root 3 and root 3 get cancelled and result is minus 17, which is integer also, and every integer is the rational also. Third example, product. If I say one of the number is root 2, another number is root 18, their product root 2 into root 18 become root 36, which is coming 6, is natural also, whole number also, rational also and integer also. Fourth, if I take root 12 and root 3, both are irrationals. If I divide root 12 by root 3, it is coming root 4, which is 2, which is rational also, integer also, whole number also. So I have given you examples. You can take infinite number of examples.